All right, so we basically have talked about, we've defined our main three functions, that is cosine, sine, and tangent. Okay, we're not really, in this class, we're really not too interested in the other functions. We're going to mostly work with sine, cosine, and tangent. So now we're going to go more into the graphing of these functions, and how do we graph these functions, how do I solve equations in trig functions. But before we do that, we need to figure out what are some properties of sine and cosine function. Okay, so the most important thing we have is domain. What's the domain of my functions? Okay, so I have sine and I have cosine. Okay, so domain of both these functions is negative infinity to infinity. I mean, think about it. I can take the sine of any value I want, right? When I say sine x or sine theta, theta can be any number. It can be a positive number, it can be a negative number, it could be 0. Same way for cosine, I can take cosine of a negative number, cosine of a positive number, or cosine of 0. Okay, so the domain of these two functions is negative infinity, infinity, which means a graph will go towards infinity on the x-axis. What's the range? Okay. In all the problems we did, if you noticed, sine and cosine were never greater than 1. The highest value they ever went to, if you remember, sine of 90 degrees is 1, or sine of pi over 2 is 1, and sine of 3 pi over 2 is negative 1. Okay, so sine and cosine can never take values outside of 1 and negative 1. So the range of these functions is negative 1 to 1 included. Okay, same for cosine, I have negative 1 to 1. Okay, just for the sake of range, we can also think about, right, what did we do? We had a unit circle, and this is how we defined our sine and cosine, right? We define sine and cosine as, so if you pick a point, this is x and y, right? So we define this function to be sine and this function to be cosine. Okay, since x squared plus y squared has to equal 1, x and y cannot take a value greater than 1, because if I take a value greater than 1, then this would have to be negative, and we know that y squared cannot be negative, right? So the range for both these functions has to be between negative 1 and 1. Okay, now what are the zeros of this function? When is my sine function 0? So let's think about it, right? What is my sine function? My sine function is basically my y coordinate. When's my y coordinate 0? When it's on the x-axis, right? So here's the point 1, 0, and here's the point negative 1, 0. So sine of 0 is 0. Let's go 180 degrees. Sine of 180 degrees, the sine of pi is 0. Sine of 2 pi, 3 pi, 4 pi, so on and so forth. So zeros for the sine function are n times pi, where n is any integer, right? So it's, you could have negative 3 pi, negative 2 pi, negative 5 pi, 0, 4 pi, 2 pi, 3 pi, whatever n can be, any integer times pi is your 0 for sine function. Now when is cosine 0? What is cosine? Cosine is your x-coordinate. When is your x-coordinate 0? Basically, x-coordinate 0 means when does your function have, where does your function have a y-intercept? My circle has two y-intercepts at pi over 2, or this point is going to be 0, 1, and at 3 pi over 2, which is 0, negative 1, right? So at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, so on and so forth. So basically, my cosine is going to be pi over 2 plus n pi, right? Because I have pi over 2 is here. Add a pi, I come here. Add 2 pi, I come back here. 3 pi, 4 pi. And so at every time I add a pi to pi over 2, that's going to end up being either here or here. And so this is pi over 2 plus n pi, where again n is an integer. Okay? And then what is the period of my sine function, and what is the period of my cosine function? Well, period of my sine function is 2 pi. Okay, why? Because think about this point, all right? All my sine values are different, okay, until I get back here. And so period of my sine function is going to be 2 pi. So sine of theta is going to be the same as sine of theta plus 2n pi. Okay, and so that is your period for the sine function. Same for the cosine function, my period is 2 pi. Because if I add 2 pi to this point, I come back to the same value, right? So it's going to repeat this terminal point is going to repeat every 2 pi, and so I'm going to have the same values for sine and cosine every 2 pi. All right, and finally, I want to figure out whether they're even or odd functions. Well, if you remember, even functions are ones that are symmetric about the y-axis, and odd functions are the ones that are symmetric about the origin. It so happens, and we'll see this in our next video when we look at the graphs of sine and cosine, that sine actually happens to be an odd function, that is, it's symmetric about the origin. So sine is an odd function. What that means is sine of negative x equals negative sine x. Okay? And cosine happens to be an even function, which means it is symmetric about the y-axis. And here I have cosine of negative x is equal to cosine of x. Okay? So sine is odd, that is it's symmetric about the origin, and cosine is even, that is it's symmetric about the y-axis. So these are the properties of sine and cosine functions. These are something that I expect you to know, and I'm definitely going to put one of these on the quiz.